Hello students, I am Vishwajit Bhattacharya, Physics faculty of AEP team. Today we will discuss the chapter optics, but it is a very big chapter. We only discuss today the topic image formation by concave mirror. Okay, image formation by concave mirror, and there is two subtopic for today, that is ray diagram rules, and another one is different types of image formation. Okay, first thing, we already in previous class we already discussed some theory regarding the reflection of light, right? You know that what is reflection? What is reflection? You also know that the laws of reflection, and also we discussed about the image formation by plane mirror. These three subtopic we have already discussed in previous class, right? Main thing is that in case of laws of reflection, we know that there is a law, like if this is a reflector and a ray incident on this reflector, reflected ray, this is incident ray, this is reflected ray, and you know that this is angle of incidence, this is angle of reflection, and you also know that these angle of incidence and angle of reflection always equals, right? So this is very important for this topic also. And image formation by plane mirror, you know that the image formation by plane mirror is virtual in nature, is the size of the image is equal to the size of the object, and also you know that the object distance and image distance will be same, right? And these are the subtopic which already discussed in the previous class. Today we discuss about the image formation by concave mirror. This is not a plane mirror, this is basically a curved mirror. And you know that curved mirror is basically in two types. One is concave mirror and another is convex mirror. We discuss about the convex mirror in next class. We only discuss today about the concave mirror. Like any type of curved mirror prepared by you have to take a section of this hollow spherical glass, and you have to take a section. If you take this section, and you have to prepare a reflecting surface. If reflecting surface is this, then this mirror is called concave mirror. That means in case of concave mirror, you have to polish the surface which is outside the sphere, right? And if you polish the surface inside the sphere, then it will make a convex mirror. Okay, this is a concave mirror and this is a convex mirror. Any type of curved mirror, there is a center, right? Because this is a section of a sphere, this is also a section of a sphere, hollow sphere, right? So any type of mirror, like maybe concave, maybe convex, there is a center, right? Center, which is called center of curvature. This center is called center of curvature. Like this figure, you see this figure, this is a sphere, glass sphere, hollow glass sphere, and we cut this portion and polished outside the sphere, polish the surface which is outside the sphere, and this is called concave mirror. So in case of concave mirror, this center is called center of curvature, and if this is a curved mirror, there is a center of this curved surface, right? Central position, not center. Center is, this is the center and called center of curvature, but there is a central position of this mirror. This central position, this central point is called pole of the mirror. That means this is pole of the mirror, right? This is pole of the mirror. And if you join the center of curvature and pole of the mirror, the straight line is called principal axis. That means, what is the principal axis? Write it down. What is the principal axis? What is the definition of principal axis? This is the line joining between the center of curvature and pole. This is the line joining between the center of curvature and pole is called principal axis. Okay? That means this is principal axis. And also you have to know that the distance between the center of curvature and pole is the radius of curvature. Okay? Center of curvature and pole is called radius of curvature. That means radius of curvature is the radius of the sphere, original sphere. Is this clear? So you have to define the terms like center, like pole, like principal axis, like radius of curvature. Okay? Next, say in this figure there is a parallel beam of light incident on the principal axis. Okay, there is a parallel beams of light incident on the principal axis, and after reflection each rays converge at a point on the principal axis. That means this is a concave mirror. If you draw a parallel rays which is parallel to principal axis, after reflection this ray, reflected ray, meet at a point on a principal axis, and all the rays which is parallel to the principal axis converge at a point, after reflection converge at a point on the principal axis. This point is very important. This is called focus point. Okay, and we denote it as F. F is the focus point. So what is the definition of focus point of concave mirror? In case of concave mirror, if some parallel beam of light incident on a mirror, and after reflection they will meet at a point on the principal axis, this point is called focus point. Okay, that means focus point. And focal length, which is called the distance between the focus and pole. Focus and pole, the distance between the focus and pole is called focal length, which is also very important term. And see, there is a center of curvature, and you have to memorize it that center of curvature and pole, focus is situated at the midpoint between the center of curvature and pole. Okay, always focus is situated in between the center of curvature and pole. Midpoint is the center of curvature and pole. That means we can conclude that the radius of curvature, if radius of curvature is r, then r by 2, half of radius of curvature, is equals to focal length, because here CF distance is equals to FP distance. That means CP is the radius of curvature, so half of radius of curvature is equals to focal length. And this relation is also applicable for convex mirror also. Okay, we will discuss in next class, and this is the rules for each type of mirror. Okay, curved mirror. That means F is equal to R by 2. Okay. Next we will discuss about two factors. One is focal length of a mirror depends on which factor? Obviously, focal length of a mirror depends on center of radius of curvature, means position of the center of curvature, right? That depend on focal length. Focal length depends on radius of curvature. This focal length only depends on radius of curvature. And there is another thing we will discuss. This position, that means the cutting position of the mirror, is called aperture. This aperture may be a very big aperture, maybe a mirror contains a small aperture, right? If you cut this portion like this, then the aperture of the mirror will be bigger. Then what is the effect of this aperture on the image formation or focal length, etc.? So, first thing, big aperture or small aperture, bigger aperture or smaller aperture. Basically it varies the amount of light reflect from the mirror is greater or lesser. That doesn't depend on the focal length of the lens. Okay, only this is if aperture is very bigger, that means the amount of light reflected from this mirror is higher, right? So that depend on, basically that varies the factor, which is the amount of light reflected from the mirror. Okay, I think that is clear for you. First thing, focal length doesn't depend on the size of the aperture, mind it. Focal length doesn't depend on the size of the aperture. Basically focal length only depends on the radius of curvature. But in case of bigger aperture and in smaller aperture, basically that varies the amount of light reflected from the mirror. That means if the bigger mirror means bigger aperture mirror, this obviously in this case the image will be very sharp, right? In case of smaller aperture of mirror, the image is somehow fainted, right? Fainted. It is also applicable for plane mirror also. Mind it, plane mirror. If plane mirror is very big, then the image will be very sharp. Okay, reflected image is very sharp. Okay. Next thing, when we draw the images, you have to maintain some rules. Rules for concave mirror in case of ray diagram. When we draw the image formation or ray diagram, then you have to follow these 4 rules. Okay, 4 rules. Number 1, mind it. Number 1, if a ray incident on the mirror parallel to the principal axis, then obviously after reflection it will move from the focus point. Very important point. Okay. Second case, if a ray incident on a mirror through the focus point, then after reflection it will be parallel with the principal axis. Just reverse of these rules. Second law and first law, reverse rules. If parallel rays parallel to principal axis incident on the mirror, then it will move after reflection through the focus point. And if a ray incident on a mirror through the focus point, then it will parallel to the, after reflection it will parallel to the principal axis. Okay. Number 3, if a ray passing from center of curvature, then it will reflect back if by the same line, right? By the same line. Why? Okay, we will discuss this thing. Number 4, it is not applicable in case of ray diagram, but you have to know that if a ray incident on a mirror at an angle like theta, then it will reflect with the same angle, because we know that the angle of incidence is equals to angle of reflection. So this angle should be this angle, but it is not very widely applicable. Basically in these 3 rules we can make the ray diagram for image formation. Okay. So in this case, if a ray, you know that if a ray incident normally on a reflector, then it will reflect back in the same line, because the angle of incidence, angle of reflection both are 0 degree. Okay. So in this case, if a ray coming from the center of the curvature, if you draw this tangent and center of radius of curvature will be perpendicular, so the ray incident perpendicularly, so reflect back by the same line. Okay. So these are the 3 rules, is very important for ray diagram. In case of ray diagram, first thing you have to draw first you have to draw a straight line, then you have to take 3 equidistant point. Okay, 3 equidistant point. That means, say this is pole, this is focus point, and this is center of curvature. Then you have to draw an arc from P point, okay, and then you have to draw first the position of the image, and then with the three rules of ray diagram you have to draw the image formation, okay. So first thing, number one, if an object placed beyond the center of curvature, this is focus point, this is center of curvature. If an object placed beyond the center of curvature, first you have to draw a parallel rays parallel with the principal axis. Obviously it will move through the focus point, right? This is reflected ray. And another one, if the ray passing from center of curvature, it will return back by the same line. So this is the intersecting point. This is the intersecting point, and at this point image will form, and as the reflected ray actually meets at this point, so the image will be real. So you have to write the character of the image. First thing, the image formed between the center of curvature and focus point. That means if an object placed beyond the center of curvature, if an object placed beyond the center of curvature, then what is the position of the image? Obviously position of image in between center of curvature and focus point, okay. That is the first characteristic. Second characteristic is the image is real. The image is real. You know that the real image and virtual image, this image will be real image. Number 3, is the image diminished or enlarged? Obviously this image is diminished in size. Diminished in size, right? Number 4, it is inverted or erect. That means inverted means this head point, basically this is the head point, okay. That means the image will be inverted. A minute. So this image will be inverted. These 4 are the basically characteristic of this image, right? First thing, this is a real image. This formed in between center of curvature and focus point, and this is a diminished image. Size of the image is small than the size of the object, and the image will be inverted, okay. Is it clear? In case of, if object move towards the mirror, then this image will move away from the mirror, okay. This image in this case, like if object placed at center of curvature, okay, if object is placed at the center of curvature, then if you draw the image formation, first you have to draw a parallel light which is parallel to principal axis, and it will move after reflection through focus point, and another line through focus point, it will move parallel with the principal axis. So this point is the intersecting point. You see, the position of the object and the position of the image is same, as well as see the height of the object and height of the image is also same, but only difference you know that the in this case position of the means size of the object and size of the image will be same in case of plane mirror, but this image is real, but in case of plane mirror the image is formed virtual, right? So what is the character of this image? First thing, the image formed at center of curvature. Center of curvature. Number 2, the size of the object and size of the image is same. Size of the object is same as size of the image. Not diminished, not enlarged, right? Size of the object and size of the image will be same. Number 3, see, this is a real image, and also it is inverted, right? It is inverted image. So in this case, the position of the object is at the center of curvature and the position of the image is also at the center of curvature. Number 2, size of the object and size of the image is same, and number 3, this image will be real and inverted. Okay, this is the characteristic of image formation when object is at center of curvature. Next, if the object also move towards the mirror, then when it is placed in between center of curvature and focus point, if we draw a parallel beam of light, it will move after reflection through focus point, and another one, if the ray coming from focus point, it will move parallel with the principal axis. So image will form at this point, which is beyond the center of curvature. Then what is the characteristic of this image? First thing, it will form beyond the center of curvature, beyond C. Number 2, it is enlarged image, enlarged. And number 3, it is also real image. And number 4, it is inverted image. These are the characteristic of the image. Okay, is it clear? And when object is placed at focus point, like at this focus point, if object is placed, then you have to draw two lines, like one is from center of curvature, reflect back in same line. It is the laws of fourth law, use this law in this case, but you may take this law also. If a ray parallel to the principal axis, then it will move from the focus point. See, these three rays are parallel to each other. That means they do not meet at the like in infinite they will meet. Okay, in infinite they will meet. So the image will form at infinity. Infinity. Number 2, image will be real. Number 3, image will be enlarged. And very big image is formed. Okay. And number 4, this is also real, means inverted also. Okay. These are the characteristic when object is placed at the focus point. Okay. Next, when object further move towards the mirror, say object is placed in between focus and pole, then one ray parallel to principal axis move through the focus point and another ray move from center of curvature. These are the meeting point, right? Because in this case, if we draw these rays, then it will never meet at this side. Okay, so meet at this side, actually don't meet the light, so virtual image is formed. Okay, that means characteristic of this image will be, first thing, image is formed back side of the mirror, back side of mirror, right? Number 2, it is enlarged. Number 3, it is virtual image. Okay, this is virtual image. And number 4, actually enlarged, virtual and erect. Okay, this is not inverted, this is erect image. And basically this position used as actually shaving mirror. Okay, in case of shaving mirror we can use this law. Okay, next we will discuss 2-3 questions. Like, you try to solve this question first. First, say this is focus point and this is center of curvature. If a ray parallel to principal axis incident on this mirror and reflect from the focus point, say this angle is 60 degree. This angle is 60 degree. Then what is the angle of incidence? What is the angle of incidence? In this case, first you have to join center of curvature and the incident point. Okay, basically this is the normal. This is the normal at the point of incidence. And you know that this angle is angle of incidence and this angle is angle of reflection. And both this angle is same. So this is I, this is R. So I and R are same, and I plus R is equals to 60 degree given. That means I will be equals to 30 degree. The answer is 30 degree. Okay. Next question. Next question, say this is a concave mirror this is focus point, and this is center of curvature. Okay. First you put and point object at this point, and it will move towards the mirror. It will move towards the mirror parallel with the principal axis. Parallel with the principal axis. First, if this point is placed beyond the center of curvature, then you know that the image will form initially at this point between the center of curvature and focus point. If object is placed in object is moved towards the mirror with a certain velocity, then what is the direction of velocity? What is the direction of velocity of this mirror? Like in this direction, or in this direction, or in this direction, or in this direction. Which one is correct? 1, 2, 3, 4. First try to solve it. First thing, when object is moved towards the mirror, obviously image will move away from the mirror. But here, if we treat this object, this is the object, then the image will like this. When this object moves towards the mirror, obviously image gradually size of the image increasing. That means this point will move towards along the line 3, right? That means 3 is the correct option. Okay, is it clear? Like this we will discuss some questions in next class also. This is for today class. Okay, thank you.